and welcome to today's webinar, In Building Cellular, Enabling the Smart Building. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented by Ericsson. Facility occupants are increasingly demanding secure and ubiquitous wireless connectivity for their cloud and mobility-based applications. Meanwhile, when it comes to managing the building itself, emerging technologies such as sensors and remote access and diagnostics are being put to use to help increase efficiencies. To fully apply these technologies, the right networks need to be in place. So during this webinar, your speakers will explore how small cells can enable the reliable and secure network you need to manage your facility and to deliver the secure coverage and capacity your occupants expect. Before we get started, I'd like to note that we will do a Q&A at the end of this webinar. So please submit questions via the question box in your panel at any time, and our speakers will address them after the presentation. Now I'd like to introduce your speakers today, Lori Blair and Jeremy Hidalgo. With over 19 years of experience in the wireless industry, Lori is Customer Solutions Sales Director at Ericsson. In her role there, she is responsible for growing enterprise sales of indoor small cell solutions through an indirect channel program. Prior to Ericsson, Lori led the Distributed Antenna Systems business segment at Hutton Communications. In her role as Vice President of DAS Solutions, she was responsible for the development and execution of customer and supplier strategies. Lori's dedicated focus to in-building cellular coverage solutions began in 2002, and she continues to remain in the forefront of this evolving sector of the wireless industry and the dynamic future ahead. Your second speaker today, Jeremy Hidalgo, is with McKinstry, and he has been the engineering and account lead for some of the largest wireless deployments in the Pacific Northwest. His first WLAN project, starting in 2004, provided experience in RF design, installation, deployment, project management, and configuration of wireless access points numbering in the thousands. This also provided the opportunity to begin engineering DAS, and in 2006, he designed his first large-scale multi-building neutral host DAS. This has led to successful deployments in the wireless market, and clients include school districts, medical facilities and hospitals, shipping and logistics warehouses, mixed-use high-rise buildings, and private foundations. And with that, I'll hand it over to our speakers. Lori?
Thank you, Ann, for the introduction, and I'd like to thank our audience as well for their time and interest in joining us today. To start, I'm going to spend just a moment with some information regarding Ericsson for those who may not be as familiar with our company. So Ericsson is a 140-year-old company. In fact, earlier this week, we celebrated the 140-year anniversary of Ericsson. Ericsson is a world leader in mobile network equipment with customers in 180 countries. Here in North America, we have over 14,000 employees. More than 40% of the world's mobile traffic is passing through Ericsson network equipment. And we're the world's largest supplier of LTE technology with more than 60% market share. Suffice to say, Ericsson knows mobile technology. As we get into the presentation today, we'll talk more about some of the drivers related to the mobile data traffic growth and what's causing the significant demand for the radio networks. With Ericsson's world-class engineering and long-standing expertise, we feel that we are a very perfectly suited partner for enterprises as they transform their communications and their networks. And with that, I'll turn it over to Jeremy to provide an introduction regarding McKinstry.
Thank you, Lori. So founded in 1960, McKinstry developed a philosophy for the life of your building, which supports our commitment in taking responsibility to design, build, and sustain our clients' facilities. McKinstry's philosophy stems from our cycle of services, which incorporates our areas of expertise in design, pre-construction, construction, commissioning, maintenance, and management. McKinstry is a company that works with developers and building owners, designs a building to meet energy and technology needs for tenants, and we focus on the tenant experience and facilities manageability. Ongoing data gathering is paramount, and we provide construction services in the Pacific Northwest as well as energy management throughout the United States. Our in-building wireless group specializes in offering design, engineering, installation, commissioning services for major Fortune 100 companies. Cellular carrier relationships and work directly for the carriers is also another service we provide. Cellular, public safety, WLAN and Wi-Fi, mobile engagement, data transport and backhaul, are all a number of services that we provide to help enable the connectivity of a building. I'm going to turn this back over to Lori.
Okay, so let's spend a few minutes talking about some of the market trends and what's driving the need for indoor cellular connectivity. So first we have the continued growth in mobile data traffic. This is in large part due to the number of mobile subscribers, which is expected to reach 9.1 billion by the end of 2021. And with that is the growth in the smartphone traffic, which is expected to increase 11 times in the coming years. Much of this increase is resulting from the use of data-rich content such as video. The media is increasingly going mobile, and users are wanting to access their favorite media content anytime and anywhere. In fact, by 2014, watching on demand had outpaced broadcast TV. So all of this data traffic is putting capacity demands on the networks. And whereas in the past, we've been focused on delivering connectivity outdoors, the fact is 70% of the use is occurring inside of the buildings. And so it's now imperative that we bring the technology indoors. We should also talk about the changing workplace and the great ICT transformation. More and more companies are moving to unwired and mobile workplaces. For instance, even here at Ericsson, we're in the midst of going through a shift towards freestyle seating, where employees are not assigned a dedicated wired desk. Everything is completely mobile. A lot of the work is taking place on smartphones and tablets, supplemented with laptops when a larger computing platform is needed. As well, many companies are moving their infrastructure to the cloud. It's expected that by 2020, 70% of companies will be running infrastructure in the cloud. This is all enabling improved business efficiencies and productivity. In fact, from a recent survey, it was found that 7 out of 10 CIOs or CTOs find mobility to be mission critical for their business. We should also talk here about the massive IoT or Internet of Things, maybe some of you have heard about. With IoT, there's the expectation that in the coming years, billions of devices will be connected. Much of this will be enabling smart building applications. The factor to keep in mind is that users will be accessing this information and these applications in many cases from their smartphone devices. And so connectivity will be imperative to enable this ecosystem. Many of the IoT applications are being standardized on LTE technologies. Ericsson has a vision of the network society based on the main drivers of mobility in the cloud, and it's now being realized. That vision entails every person in industry being empowered to reach their full potential. And many others in the ICT industry are supporting it, as evidenced here by the quote from Microsoft's CEO. Indeed, the fully mobile world is upon us. So let's talk about, do we need cellular inside of buildings? We say yes, we do, for a number of reasons. Workers are demanding good coverage. From a report that was done last year, we found that 60% are not satisfied with indoor service, and 70% do not think the quality is satisfactory, which leads us to believe there's a lot of work to be done in improving connectivity inside of the buildings. As we've talked about, the data traffic is only increasing, and 70% of this usage is occurring indoors. While voice remains important, data and video will be comprising much of the usage, thus putting more demands on the capacity of the network. Additionally, more devices are being connected, such as tablets and wearables. Again, the users want ubiquitous coverage for all of these devices. Additionally, we see Wi-Fi as a complementary technology, but not a replacement and not enough of its own. In a mobile-first world, we see LTE and Wi-Fi working hand in hand to solve all of the various use cases. And with that, I'll turn it back to Jeremy to talk about high efficiencies for the buildings themselves.
Here's a snapshot of some of the building systems that are now monitored as part of both new construction and retrofits. As sensor technology evolves and the Internet of Things becomes a bigger part of the building's ecosystem, LTE is playing more of a role in providing a communication layer that we are using to gather the data we need. Data collection for energy is used for energy monitoring, occupancy sensing, and also providing connectivity to tenants and visitors. McKinstry uses this information to optimize energy consumption, facilities' ability to respond to building issues, and we do that by enabling access to data relevant to the building systems throughout. This also allows McKinstry to meet the demand for the Internet of Things and in the increasing trend in smart home technology for residential applications in multi-tenant residential buildings, such as smart appliances, security, access control, and energy management, which is moving toward LTE as a standard. Turn this back over to Lori for the next slide.
And yes, something else to keep in mind, as we look at building more energy efficient buildings, much of the materials that are used for the insulated windows and the UV protection can actually worsen the indoor connectivity because the cellular signals are impeded. So this is something to keep in mind as these types of initiatives are underway, that it really goes hand in hand when you're building a greener building that you very well may need a dedicated in-building cellular system. Something else to point out here as well is that the outdoor macro signals are shared with other buildings, people on the streets, etc. And as the capacity demands continue to grow, as we've been discussing, again, it'll be very important to have dedicated capacity coverage inside of the building for the vast majority of users that will need connectivity. So now we'll get into the Ericsson Radio Dot solution, which is redefining small cells for the enterprise. First, let's briefly touch on some of the other in-building solutions that have been around for a while and for which Radio Dot is a new, more technically advanced alternative. Some of you may be familiar with or have heard of DAS, which stands for Distributed Antenna System. DAS is designed primarily to support narrowband coverage and voice and is inadequate to handle the significant growth and capacity requirements driven by the escalating data traffic in the enterprise. It's also costly to add capacity to an existing DAS. Also, DAS equipment requires a lot of space, and where floor space is at a premium or needs to be revenue generating, this can be a very big issue for the building owner or manager. Additionally, DAS requires a lot of power to operate, which can drive up the energy cost. As for another solution being femto cells, these are consumer grade and work fine for simple residential applications. However, in larger business settings, noisy radio environments cause interference with femto cells that results in poor user experience and performance. With all of this said, DAS and femto just cannot solve the current and future demands that the enterprise are placing on their in-building communication networks. So let's take a closer look at Radio Dot. It's a revolutionary solution that offers the performance and reliability of carrier-grade telecom solution, but it's designed to be streamlined and simple to deploy, like IT platforms and systems. The Radio Dot is ultra compact to fit anywhere gracefully with minimal visual impact. and it's very lightweight at just 10 ounces per dot. It literally fits in the palm of your hand. Deployment is very easy, as existing LAN cabling can be used, and it requires a small footprint in the equipment room, which frees up space for the property owner to monetize the additional square footage. The radio dot system delivers high data rates and offers the capacity and coverage that the transforming enterprises will need. Capacity allocation and expansion is dynamic and modular to keep pace with the growing needs. For medium to large buildings, radio dot is cost-effective on a per square foot basis and can be included as part of the facility's infrastructure, just as water, power, and HVAC are done currently. The Ericsson radio dot system is the industry's most cost-effective and modular high-performance indoor radio system. It's bringing reliable and fast indoor cellular connectivity in a sleek and elegant design that does not disrupt the indoor environment. The system is cost-effective in a wide range of building sizes, typically starting at about 100,000 square feet and greater. It has fast and easy deployment using standard Ethernet cabling, and the CapEx and total cost of ownership is low. Additionally, the radio dot system is integrated with the service provider's mobile broadband network for feature transparency and a seamless managed user experience. To summarize, the radio dot is the best option for commercial buildings, enterprises, and environments when connectivity is mission critical, offering superior coverage, capacity, and TCO than other technologies, and is simple and cost-efficient to deploy and manage.
Excuse me, Lori? Hi,
Yes.
it's Ann. We actually have a few questions just kind of covering some of the content you were just covering, if I could jump in. We did have a question about the square footage. You had talked about
Okay.
reach. So can you just kind of give an anecdote or two about how much square footage a radio dot would cover?
Yes. So each dot in a typical office environment coverages on average about 8,000 square feet per dot. And each dot, the dot connects to an indoor radio unit, which connects to the digital unit where the signal source is located. With one digital unit, you can have a total of 96 radio dots, so essentially around 700,000 square feet of coverage with one head end, so to speak.
Thank you. And then also just to reiterate on the technology, how does radio dot differ from Wi-Fi that may be in many buildings already?
Yes, so radio dot operates on the operator's licensed spectrum, whereas Wi-Fi is an unlicensed spectrum. So with that, you have inherently just greater security features. Additionally, it's seamless with the outdoor mobile network. So you don't have the need to log on and that sort of thing, such as what you would have with Wi-Fi. And also the solution with radio dot is inherently very high capacity as well.
Yeah, I think one thing worth mentioning too is with Wi-Fi, you typically have to have your device associate to the network, and whoever owns the Wi-Fi network is going to make you go through and either be a user of that system or put you through a number of hoops in order to allow you onto their network and make you conform to certain security protocols, whereas your device is already dialed in with the carrier and allows you to have that easy transition from the outside network to the inside network. And also roaming throughout the building is something that is a much easier thing to accommodate over the dot system on the carrier networks.
Okay, thank you. And so one more question actually before we move on. Jeremy, you touched on this. Are these carrier specific, the radio dots? For example, would I need a radio dot for each of the 4 major wireless carriers within a space?
Yes, I can answer that, and Jeremy can add to it. So the DOT is operator specific and band specific. So yes, you would have, but also keep in mind the radio DOT being very minimal in size. And if you think about it in comparison to Wi-Fi APs, so where you would typically need, let's say, the extent of 4 wireless APs, that area could be covered, say, with 1 DOT. So if you have in a multi-operator solution 4 dots, you can either cluster those together or you can space them out, such as how you would do a Wi-Fi AP installation, to put it in perspective.
Okay, thank you.
Okay. And with that, I'll turn it over to Jeremy, and he's going to talk about a specific use case.
Thank you, Lori. Yeah, so I'm just going to go through a couple specific scenarios. So the first one being this 9209 office tower in Bellevue. It's among the first of the RDS deployments in the Pacific Northwest, and it's a building that has LEED Gold status. So that status makes it extremely effective at keeping out UV, so we can make the building super energy efficient, but it's also really good at keeping out cellular. And so the owner expressed a desire to make sure that he was building sustainability not only from an energy perspective, but from a technologies perspective. And putting in RDS will allow us to do that and meet the needs of the future tenants going in there. We're also using this system to help enable our ongoing energy monitoring and building-wide access. And again, a lot of that is because it's a reliable network. We don't have to rely on some other IT group to keep the network up and running, and it's carrier managed. We've found actually that because McKinstry does a lot of energy retrofits and performance contracting as part of our business model, we'll go out, we'll identify a building, we'll gather all the initial data, and then do some studies and write a proposal around doing the energy retrofits to that building specifically. Once we've done the energy retrofits, we work with the customer on a cost model for realizing the rebates from the utilities and so on. So in the process of doing this, we've actually had to add cellular remediation almost to the portfolio of these services, because we've gone out to a couple of projects and found that when we increase insulation, swap out the windows for more energy efficient windows, perhaps put metal siding on a building, we actually make it a much better insulated building from an energy perspective, but again, we're blocking out cellular coverage. We've done this on a couple of projects and had to go back and install either DAS systems, or now we're looking at the RDS for our go-to solution, because we're also using it to monitor, again, using the LTE monitor, a lot of the sensors and things that we're putting in the building to help us understand what's going on in that facility. Additionally, we're really excited about the RDS because its footprint is really minimal when compared to providing additional carrier equipment. We can bring the carriers in over backhaul, which is essentially just, we're going to have fiber and a network switch for an ISP, and then we'll be connecting it to what is essentially in buildings of the size that we've been talking about, a half a rack worth of equipment, as opposed to in the past we've had to accommodate multiple racks, perhaps adding an HVAC unit to cool down that area, and the power consumption in that room where we house this equipment skyrockets. And so in keeping with our standards of making sure that the building is efficient in energy usage, we've started to roll out RDS as a part of our standard in our energy management services.
Great,
And
very
I'm going to
good.
go ahead and hand this back over to Lori.
Okay, thank you, Jeremy.
Mm-hmm.
Here I'm going to mention about the Skanska case study, which is involving a modern residential building outside of Stockholm that has energy-efficient windows and well-insulated walls that resulted in poor coverage from the outdoor macro cell site. This was a joint project with Ericsson, Skanska, and Telia to improve user experience in the building using the radio dot system. The use case included voice coverage, LTE mobile broadband, LTE video streaming, essentially providing a wireless home where TV, internet, and voice are all served by the radio dot system. And here we have a proof point regarding performance. So some may think that supplemental cellular infrastructure is not needed to support the indoor wireless needs, that they can rely on the outdoor macro network. But unfortunately, this is just not always the case. In the example here, signal from the external macro network was measured, resulting in a decent 3.3 megabit per second. However, when Radio Dot was installed, you can see the extraordinary increase in performance, more than 10 times improvement at 60.8 megabits per second. The significant increase in bandwidth enables a wider range of mobility applications to be deployed and also increases the quality of performance. As we've been talking about, as the mobile demands increase on the network, this will become increasingly important as well. So to summarize here, we've talked about the big picture and the market trends of what's causing this continued growth on the networks that will be requiring a new approach to how we solve for these wireless needs. We've also talked about in-building solutions and the need for newer, more revolutionary solutions such as the radio dot system. We've touched on a few proof points from both Ericsson and McKinstry from real-life examples of deployments. Jeremy, would you like to summarize as well?
Yeah, I think, again, just to reiterate the fact that McKinstry is now deciding to standardize on the radio dot system as a major element in what we're doing from an energy perspective and also from a smart building perspective for a lot of the reasons that I pointed out earlier, smaller footprint as well as the ability to deliver a quality signal from the cell carriers and really, for the most part, the ability to get the carriers to participate in some kind of rebroadcast inside the building.
Great, thank you.
Great, thank you, Lori and Jeremy. This is Ann Cosgrove back. Now we will do a Q&A for some of the questions that we have on hand, and I will pose those to you now. First, just to kind of back up to some basics here, can you explain what structured cabling infrastructure is required? I think you touched on that in the beginning, but if you could talk about the infrastructure that's needed to bring this into an existing building?
Yes, so the radio dots themselves are installed utilizing common LAN cables such as Cat6A type cabling. And then the connection from the digital unit to the indoor radio unit is via fiber. And depending on the texture for the needs of that building, those units might be housed together in the MDF or with a distributed type of architecture. You may be running fiber to the indoor radio unit, which would be located in the IDF and via fiber. So it's a fiber connectivity between the DU and the IRU, and then Cat6 type cabling to the radio dot.
Thank you. And focused on that, on installation, we have a question about what are the training requirements that, or maybe challenges or highlights that you've seen, training requirements for integrators in designing, installing, and commissioning the radio dot system. And as our facilities people will be working with those integrators what has the integrator experience been or role in this been?
Okay. Yes. So the radio dot was specifically developed for very ease of deployment, and for a system integrator to be a certified partner with Ericsson in the radio dot system, there is trainings that are required as part of the program, which includes design training and hands-on installation training. So a certified partner would have to go through those trainings in order to deliver the solution to the customer. And so as an example, McKinstry is obviously a certified channel partner with Ericsson and has been through those trainings. And Jeremy may have more to add to that as to what McKinstry sees as advantages as it relates to the deployment for the solution.
Yeah, absolutely. So we've found that the training process has been extremely, well thought out and put together. It starts out, we go through some initial trainings online for our sales personnel, as well as some of our engineering to get familiarity with the product, and then we send a number of engineers down to Ericsson facilities in Texas for more detailed instruction, both around the design of the system as well as commissioning and install. And I think the thing that drew us in more than anything else is the fact that Ericsson is so very selective about who they bring onto the partner program. We've seen in the past with other manufacturer partners that at times they're out there grabbing anybody and everybody they can who they think can further their cause without necessarily putting them through any kind of vetting process to make sure they're installing a quality product. And that's detrimental to all of us in the industry. So the fact that Ericsson has done that with us and other partners that they bring on is very attractive to us.
Thank you, Jeremy. Okay, and then we do have a question about the actual technology, just wanting to kind of make sure they have a handle on that. The question is, I'm not sure I understand the technology. Will this simply increase the different carrier cell strengths of current cell signals coming into the building, or does it do something else?
Anyway, that's an excellent question. So the radio dot solution has a component in that is a digital unit that actually includes the operator's signal source, and it's the same radio as what's utilized in the outdoor macro network. So you're essentially taking similar type technology that's used on the outdoor cell site, but putting it in a form factor that can be utilized indoors inside of the building. And so with the radio dot system, you have dedicated signal and capacity. You have essentially your own cell site, so to speak, for that building. And so unlike some other types of solutions that, like with a repeater fed DAS, they're borrowing or using some of the outdoor signal and broadcasting it in the building, and that's only solving for coverage. It's not expanding the capacity, and that's what's so attractive about radio dot, is that it's providing dedicated capacity to the users in that building.
Yeah, it's really kind of the equivalent of, mooching off of your neighbor's Wi-Fi signal for internet, or going out and paying for your own service where you've got CenturyLink or Comcast or somebody coming directly into your router that's located inside your house. You're going to get a much better performance out of something like that, and that's essentially what RDS is doing. We've got dedicated line backhaul from the carrier to the head end in your building, and then we're redistributing that throughout your building, as opposed to essentially mooching off of the macro network. So it might help illustrate things a little better.
Mm-hmm. Yeah.
Thank you. Thank you. Okay, I think we have time for just a few more questions. So I did want to get to some of these. Are there security issues with unwanted access to the systems with these radio dots in place?
No, and the reason being, keep in mind, as Jeremy and I are explaining, So the solution ties into the operator's core network, and so it inherently has all of the same security features that are running on the networks of the wireless operators. So the radio dot system functions on the same software that they're using for the macro. So all of the features have full parity with the indoor system as the outdoor network.
Thank you. Okay, and one last question, actually, and this is a general question. I might give you a chance to give some examples. In what types of buildings would you deploy this? I mean, drawing on your experience, Jeremy and Lori, or in terms of the characteristics of the product, are there specific types of buildings that are most suited or that you've seen really benefit from the technology?
Sure, yes. What we've, in our findings, the radio dot becomes most cost effective for buildings around 100,000 square feet and greater. We even recently designed a property as large as 2 million square feet. And as far as the types of buildings, some of the typical verticals would be commercial office buildings, hotels, hospitals, corporate campuses, university campuses, things of that nature.
Thank you. Jeremy, would you like to add anything?
Yeah, I'd just expand on that. I mean, McKinstry obviously works in a lot of different verticals, and our goal is to really install these systems where they fit, where we've got users that really need to experience connectivity and don't currently have it. So it's across verticals, and it really does fit a unique kind of market niche where we've got building owners that really need the connectivity, are willing to pay to put a system like this in, but have had trouble getting cellular carrier participation in the past. So that's typically a building that's between 100,000 square foot and under 1 million square feet, because carriers don't necessarily have budget cycle to provide money for a base station, and they may not have the capacity in their macro network in the area to allow an off-air solution. It's something that's really common here in Seattle, in the Pacific Northwest, is the macro networks are overloaded, so anything the carriers can do to get them off of the macro networks when they're inside the building is really attractive to them. And a solution like this, where basically what they're doing is looking at creating a backhaul connection, and the customer is paying for the rest of the infrastructure, that to us seems to be kind of the leading kind of scenario where we're seeing the most participation and interest, but really, to Lori's point, kind of across the board on different types of venues.
Wonderful. Thank you. Well, it looks like we're out of time, so I want to thank you, Lori and Jeremy, for your presentation and for doing the Q&A as well here. I also want to thank Ericsson. Great. I also want to thank Ericsson for sponsoring this webinar, and to our audience for attending. I'll let you know that a recording of this webinar will be available online at facilityexecutive.com, as well as on the Ericsson website at ericsson.com. So thanks everyone again for joining us, and have a great day.